I was John Black, super chemist. Like I was saying in the last video, if you come across people trying to push methane, it's a greenhouse gas and blah blah blah. It's at 0.0000017%. Okay, you can't just throw one molecule into a atmosphere in a planet and it just becomes magically a greenhouse gas. You get you're gonna have a lot of the molecules, like 10%, 5% of the air has to be CO2 for start even start to affect anything. And the trick is, one of the tricks that I noticed is they'll try to compare it with charts of carbon dioxide and methane, right? And one chart will have, or the other, all the charts with the CO2 will have parts per million, right? And the methane charts, they'll have parts per billion, and they'll always have one, at least one CO2 chart right next to the methane chart, you know what I mean? And what they do is, because, see, parts per million, you need 1,000 times as much to be parts per billion. It's not like 10 times as much, okay? 1,000 times. It multiplies the length of the peak by, that much. I mean, 1,000 times. So if you have a little bump there, now it's 1,000 times that bump. And if if the bumps are, the peaks are too high that it doesn't look like it's, comparable to the carbon dioxide, they'll just mess with the, you can always make lines, you can say this is an inch on the paper, but it's, 10 feet. Well, all I have to do is make this bigger, right? Now this is 10 feet. You know what I mean? I can just mess with the y-axis and then elongate it, you know what I mean? That way the peaks look like they're bigger. Then when you put it next to it, since it's 1,000 times, multiplied just by going to parts per billion, they're going to look similar. And then it'll be like, well, you don't believe in the climate crisis, you racist, transphobe, and then of course the person is, if they're weak, they're going to say like, oh yeah, I believe in the climate crisis, I believe in it, and then they'll be like, well, look, you ain't got eyes. The two charts look exactly the same, man. If it's, geez, it's better not have, my camera better not have went out again. Now come. Oh, there we go. Thank God. Now I lost my train of thought. But yeah, beware of that. They manipulate charts by making, and I'm going to tell you something about this next chart, because not this one, but the next one after that. So I think I got this chart out of the way. I want you to realize, too, you see right here, this biggest height, that's 7,000 parts per million. And we're at 400. And it was at 7,000, okay? And that's it. That's it. 7,000. That is oh wow, 7,000. Well, 7,000 is 0.7%. 0.7%. And we said that you can get CO2 up to 5% before it's lethal, right? Where it starts getting you sick, and the more and more you get, the longer you're in it, the more you're going to die. So we can withstand. Google just said, we can withstand. Here, let's just Google it right now. Where is it? Yeah. Can humans live in 5% CO2? No, humans cannot live in 5% CO2. Yeah, I looked this up because I thought in the last video I could have sworn that it told me it was 5,000 parts per million. But anyways, so it says you cannot live in 5% as it is considered extremely dangerous and could be fatal. Levels above 1% can cause noticeable health issues. I don't believe that. And a concentration of 4% is considered immediately dangerous. So I'm just curious now. What is 1%? Well, if 5,000 parts per million is half a percent, and they're saying, what, 1%? Well, then that's 10,000 parts per million. 10,000 parts per million is 1%. 10,000. And they're saying basically anything below 1%, you ain't even going to notice it at all. Like it's just going to be great and fine. 1%, 10,000. Yeah, 10,000. So let's go back to this chart. $10,000 is above this. There's never been enough CO2 to in the last 650 million years. Actually, 750 million, because this is going to go down. If you can see a longer chart going back to snowball Earth that ended about 750 million years ago. So none of this CO2. We could live in all this CO2, and it still wouldn't. Like 1% is 10,000, and this is 7,000. So we would be even fine there living. So, because sooner or later they're going to be like, it's going to kill us. We're going to die if we have too much CO2. I want everyone to understand, they're spending trillions right now. They're making pipelines like they do with, the oil and the gas or whatever, like the the pipelines and stuff. But these are pressurized like 20 million, atmospheres or whatever. And obviously, I'm over exaggerating. But it is pressurized, like as pressurized as you get any gas. And it's not as much that it's explosive, but any container that is that pressurized, when it blows, it's going to blow out a lot of stuff. You know what I mean? A lot of stuff's going to come out. And your car isn't going to work. You're going to have a big, giant cloud just moving across the land, just killing everyone. Because what it does is, it doesn't matter what the percentage is. If it moves enough oxygen out of the way, you know what I mean, you will suffocate. You know what I mean? And at 10%, you instantly die. Okay, at 5%, you start getting sick or whatever. But you can handle 5%. It's no big deal. But maybe a week or two later, you ain't gonna like it. Then you get to 6%, and maybe not even you last no week or whatever. But my whole point is, I forget what my whole point was. I just totally lost my train of thought. Well, maybe I'll get it next time. What else was I on? Oh, that's what I was going to say. Sooner or later, they're going to say, oh, they started these pipelines, right? Pipelines, that was it. They're going to spend trillions. Okay, they've already went through a bunch of states. They want this to be like our water lines, man. I'm talking a lot of pipes, man. People are dying because these things are exploding, you know what I mean, because of the pressure, and then they're killing everyone. See, when the carbon dioxide comes out, your car ain't going to work either. You know what I mean? People don't know what CO2 is. A lot of people are going to die from this, I'll tell you that right now. They're already dying. This is actually, I've seen bunches of reports on it, but people don't want to look. They don't care. You know what I mean? But yeah, the CO2 is going to come because how's your gas going to work? You need an oxidizer, and you get that oxidizer from the oxygen. And if the CO2 comes in and pushes all the oxygen out, how is your gas going to mix with the oxygen and burn? It ain't. And you ain't even going to know why. You know what I mean? And CO2 doesn't smell. You know what I mean? So, sure, if you're right there and you hear it and see it, it's going to be a big cloud that you can see what it's coming out, being pressurized, you know what I mean? But after a while, it's just going to go right into the air, but it's still going to be concentrated. You won't see it, you won't smell it, and even if you, like, someone dies and you know that the CO2 pipes are there, you know, people. I'm telling you, people are going to die, and they're spending trillions on this because they want to take the CO2 and they want to pipe it somewhere so they can react it with something that makes like carbonate with it. You know what I mean? Like react it with acid or base or something like that. You know what I mean? And make it into a solid. And that way they take it out of the air. But remember, for 800,000 years, okay, right here, this flat line, right? Every 50,000 years, we got down to almost, or did get down to, 180 parts per million CO2. And you die, and everyone on the planet, and all the plants, everyone, everything. You can Google it. Just say, what happens to everybody when it's 150 parts per million CO2 concentration? And it'll say everyone will die, animals, plants, and humans, because you can't live in that. Okay? That's and we're right there. And what's funny is, wait. Oh, wait, I'm not seeing good. Yeah. But anyways, yeah, it's crazy. Yeah, they want to spend trillions of dollars to, and what we need is to, this uplink. See that where we went up? We need that. We can take it all the way up to here and it's no big deal. Okay, and this is at 70, this is at 7,000. This is at 400. It's not like we're going to get to 7,000 in a second. You know what I mean? Anyways, let's move on to the next chart, which is, nope, this one. All right, now this one, these two charts, the one I just we were just talking about, and this one right here, they're the only two I know about, and I look good for these, but it's hard to find these kind of charts where they go back 500, 600, 700 million years, okay? And someone might think that it's kind of fishy or whatever. There's only two charts. But how many people do this kind of thing? You know what I mean? Everybody just uses these two charts. And you might say, oh, they're different. And they are different, okay? For one, this over here, remember this to here, that length from here to here, that was only 1,000,000 miles. A million years on the other chart. And then the next inch was like 10 million, and the next inch was like 30 million. By the time you got over here, it was like 130 million for that inch. So this is even, though. Every inch is 50 million, you know what I mean? And also, you'll notice that this has the ice age going on a lot longer than on the other chart. And this right here is more of just a loop instead of these ups and downs, you know what I mean? And this was kind of straight over, a bump, and then, down to there. But considering that, I don't know where they got the core samples. They might have got the core samples from somewhere else, and you know what I mean? And also, anytime you're dealing with anything that goes back 500 million years, you're not going to have the same results every time, man. I mean, you know what I mean? But it's not like measuring the temperature for the last 5 years. We're talking 600 million years. This chart is, and that's another thing. This chart is only 500 million years. The other one was 650. This one doesn't plot the CO2. But did you notice? So the blue and the red is the same line. It represents temperature. Okay. And I want you to look at where the line is, this dotted line. It separates the red from the blue. Now, why is that line there separating things? And that's about room temperature. It's about 65 degrees. Okay, somewhere around there. Ah, jeez. Oh, well, I'm running out of time.